Welcome back to another day of a question a day keeps the low ATAR away. So today is day four. We are doing trapezoidal rule today. So trapezoidal rule, just remember, it is an approximation, which means that your equal signs will look like this, and also your formula will be something like this. That's what you'll get in your reference sheet. So that there is the formula. Okay, so first question here. Use two applications of the trapezoidal rule to estimate the area of the cross-section of the wall. So what we're doing here is we're doing two trapeziums. The first one is this one. The second one is this one. Okay, so there's application one, there's application two. And so let's do this. Let's also note here the height for each of these trapeziums is not going to be 8 because I'm splitting them in half, which means each height would be 4 and 4. Okay, so in this case here, for area 1, it's going to be approximately height over 2, and then DF and DL is my first measurement and my last measurement. So in this case, it would be 1.9 or 2.7. 1.9 plus 2. Ooh, why did I write 1.97? 1.9 plus 2.7. That's area number 1. And while we're here, let's do area number 2. So the height again should be the same. It should be 4 on 2. And this time your two measurements are 2.7 and 1.7. Oops, and don't forget, formula inside the bracket is plus. So now if I calculate these together, it should be 2 times, should be 9.2 meters squared. And then for this one should be approximately roughly 8.8. And so your total area is going to be 18.0 meters squared. There you go. There's that one. Okay, now your second question is slightly different. There's a lot going on here. It says the shaded region in the diagram represents a garden and the scale is 1 centimeter equals to 5 meters. Use two applications of the trapezoidal rule to calculate the approximate area of the garden. So just remember the shaded region is the garden. So that there's my garden. Now, if I'm to do two applications, you can see here that there's 1, 2, 3, 4, 5, 6, 7, 8. So that means to split it evenly, I'd split it into 4, 4. So as you can see, that would be my middle there. You can see that there's going to be two distinct sections. And they've actually helped us out here by drawing us our lines. Okay, now for this one here, my height here would be, it's 4 centimeters, but that 4 centimeters really represents 20 meters. Okay, because remember, if 1 centimeter equals to 5 meters, that means 4 centimeters equals to 20 meters. Okay, so there's 20, and that's that. Now here, we're going to do the same thing. That's 1, 2, 3, 4, 5. So that means 5 centimeters would be 25 meters. So that would be 25 meters for this measurement here. This one here is back down to 20 meters. This one here is 20 meters by the same merit. Okay, so just to remind you, the trapezoidal rule is an approximation by using trapeziums, or for this particular case, it's a trapezium and a rectangle. So let's find the approximations using two approximations. So area, let's talk about area 1 is going to be height on 2. So 20 on 2, 25 plus 20. And so I'm pretty sure I can do this math in my head. It's this one here is going to be 450 meters squared. Okay. The area 2, it's going to be 20 on 2 again. This time it's going to be 20 plus 20 because that's your first and your last. That should give you 10, that should give you 400. Okay, so that means it's approximately 400 plus 450, which is a total of 850 meters squared. Okay. Second part of your question says, should the answer to part A be more than, equal, or less than the actual area of the garden? So if you see here, using those trapeziums that we drew, we have definitely overestimated because there's parts in here that we counted that we didn't need to count. Okay, so in this particular case, we want to explain our answer. So we would have to say, let's use a color. We'd have to say answer to A is more than actual area. And the reason being is, if you want the technical answer, the reason for that is the areas have concave up curves. And so that leads to a overestimation. Okay, and that would be that. If not, you're going to have to try your best to explain what's happening visually. But here, normally you want to talk about concave up would be an overestimation, and concave down will be a underestimation. Okay, so hopefully this makes sense, and I'll catch you guys in the next one. See you later. Bye.